of our review. On these problems, solve for the variable without a calculator. We're going to try to convert to the same base if we can. So actually I can get both of these in base 3. All right, it's not the only way to do the problem, but I can get both of these to base 3. That's really 3 squared. And then raise it to the x power, okay? So the 9 turns into the 3 squared. It's still raised to the x power. On this side, we have 1/3 turning into 3 to the negative first power. Okay, that's a very important rule to understand, that if you have a power to the negative first, sorry, a base to a negative first, that's the same as 1 over a to the positive first power. So if we had something like 1 over 5 to the negative second, that's the same thing as positive 2 on top. Okay, so know that rule. So now the bases are the same here. I'm sorry, there's another power to the negative 3 there. The next rule is to multiply the power. So that's really 3 to the 2x, and this is really 3 to the positive third power. So logically here, if we have the same bases, then the exponents have to be the same. So now 2x has to be equivalent to 3, so that's how we get an answer of 1.5, or 3/2 for that problem. All right, you can always check your work, but this is the work, force in a common base, that we want you to show how this works without a calculator. Okay, so then 2 to the x times 2 to the, those are all base 2 right now, so we're good. Another rule we know is that if you have bases that are the same, you add the exponents. So this is the same as 2 to the x plus 5 power equals, and I want to get that to base 2. 2 times 2 times 2 times 2, 4 times. If we do that, we'll get 16. So again, logic takes over now. If this is a true statement, then that power has to be equivalent to that power. So x plus 5 must be the same as 4. So x in this case would have to be negative 1. Be very careful of your negative answers, but up in the exponents, that's absolutely acceptable and okay there. Okay, this one here, I'm going to take root 3, and I'm going to raise that to the x power and say that's equal to 9. Again, we're sitting here and we're like, well, that's just converting to exponential. Maybe I can get base 3. Well, if I get this to base 3, that would be 3 squared. This one, something you got to kind of remember is the square root. There's really an index of 2 here, so that's 3 to the 1/2 power. A square root, raising that radicand to the 1/2, that's the exact same thing. Okay, so then we have this. So then again, our logic takes over here, that 1/2 times x must be equal to 2. So 1/2 x must be equivalent to 2. So what do we have? We've got x equal to 4 as our answer there then. Okay, now moving along to 5D, here we roll. My best advice to you, and you don't have to use it, but is to replace the natural log here with log base e. Okay, because a lot of you think that these e's, well, there's really an e here, there's an e there, there's an e everywhere. Okay, anyways, basically this becomes that. That's the same thing. But then you still have e to the x there equal to 12. So I think that'll help a lot of you before you convert it, because now it's really the base e raised to the 12th power, and that's equivalent to e to the x power. And then obviously there, the logic like we've been talking about, same base, would mean that x would have to be 12. All right, 5e here, we're going to convert this one to exponential form. So we have 4 squared, and that equals x squared minus 15x. All right, well that's 16, so I'm going to subtract 16 from both sides here, and I'm going to get myself 0 equals x squared minus 15x, and then minus 16. Solving my quadratic here, 0 is equal to, well, I'm going to factor, here we go. Factors of 16 that get us to 15. I think it's pretty straightforward. That would be negative 16 and positive 1. So our two answers here, I'm going to put these in red up here, would be x equivalent to positive 16 and negative 1. And we do want to make sure and see that these both work out. If one thing, maybe I should put this in highlighter here. You cannot have a negative as the base. Okay, I guess that didn't highlight real well. Okay, let me go like this. Maybe this will help. Okay, So highlight this, and I'm going to highlight that. Like, you can't have negative here or here, the base or what we're taking the log of. So this is okay over here, but when we plug these in, obviously the 16 will give you a positive number because you got 16 squared here minus 15 times 16, so that's going to work. Negative 1, when we put that in here, you'll get a positive 1, and then when you put it here, you'll get a positive. So you're good there. Both of these answers work. Definitely be skeptical of negatives, but they both work when you plug them in here. Okay. Last one here, it looks like they just want us to go 2 to the x equals 64. Common base there would be 2. So 2 to the x equals 2 to the, well, 4 was 16 a while ago, remember? So times 5 is 32, and times 6 then is 64. So we get an x value for this problem of 6. And that answer is completely fine. All right, down here, look at the directions. Just write the exponential equation in logarithmic form. Don't solve. Okay, so the base becomes the base. So log base 3 of 243 equals 5. Over here, log base 12 of 1 over 12 equals negative 1. If you're not so great at this, make sure you go back. Like 12 to the negative first equals 1/12. Like that makes sense. So that's easier, to do. So it's all about the base. Log base e of 12 equals x. And then you don't want to leave your answer like that ever because that's the natural log of 12 equal to x. So that would be your final answer. And then this one here, log base 10, a lot of repetition on these, of 1,000. And that's equivalent to 3. 10 to the third equals 1,000. Okay, looking at this one here, logarithmic form, get it into exponential. So this one's a little bit easier in my opinion. 3 to the fourth equals 81. Base raised to the right equals the middle. And then we have this. If you're getting confused by this, make it log base e of 1 equals 0. So you could do that. And then that would say e raised to the 0 equals 1. Okay, so that may help you there with those natural logs. This is 9 raised to the 1/2 power equals 3. Which is kind of cool if you like math here. I know I'm kind of a math nerd, but didn't we say earlier that the square root of 9 is the same as taking 9 to the 1/2? That's amazing. Okay, so anyways, if you don't see a log there, remember, if you don't see a log there, it's base 10. So that says 10 raised to the 2nd power equals 100 when we convert it. All right, so now we should be able to evaluate these without a calculator because, let's switch colors here because I'm bored with that one. This has got to equal something. You know, if you think of it that way, this has got to equal something. So 2 to the x power has got to equal 16 when you convert it. And then we get 2 to the x power equals 2 to the 4th power. So we're going to get an x value of 4. And then over here, what do we got? 1/5 to the x, because remember, this has to equal something. So 1/5 to the x must equal, put that in parentheses there, 1/5 to the x must equal 25. Hopefully you're seeing base 5. So that would be 5 to the negative first raised to the x equals 5 squared. And then if we look at our exponents here, that's negative x equal to 2. So the opposite of x equals, 2. So x must be negative 2. And remember, negative answers are completely okay when we're evaluating logarithms. Okay? All right, I'm going to stop it here and make another video for the 3rd page.